I guess one could say that it's a technology born of military purposes that has subsequently morphed into something that manages at once to be this sort of uber capitalist um, kind of practice, while ostensibly pretending to be open, or having a discourse around it about openness, and in much as we've seen in Silicon Valley, that's a real thing. And this tension is, I guess, what I wanted to explore within the simulation as well and talk about now. Is how does one embody, or how does one make more visible this crypto leviathan that is the military, media, financial, academic complex, rather than the military industrial complex, which is something that people might have talked about in, say, the 60s and the 70s. Incidentally, when researching this, I noticed there are quite a few memes going around. Some of which were about the quote unquote Rona rigs, like as in the Corona rigs. There were multi-screen home computers that Wall Street traders had set up when they were on self isolation in Cornwall and the Hamptons, or Sun Valley. I thought it quite curious that these tricked out machines could conceivably be trading global markets using machine learning algorithms, or they could be mining Bitcoin or Ethereum, whatever, while the boss man sneaks in a bit of Animal Crossing on the side. Um, I think of game engines through a stack metaphor, which is a model that comes out of the early internet. If you look at the networking protocol TCP/IP, which is essentially what underlies everything your computer or phone does over the internet, that employs a sort of a stack of how that protocol functions at the network level, at the level of the application that one is using, at the user level, and so forth. In that sense, if you look at a game engine that way, in that sense, I think they're slightly different from a traditional programming language like C++ or Lisp, even though they contain a programming language embedded in them. And I'd say they're more like the technologies that underpin the web. What could be called? You could call it sort of like a platform, which is something that theorists such as Benjamin Bratton or Mackenzie Wark have written extensively about. So it's a by platform. I think what they mean by that is it's a set of structures, practices, almost social aspects that kind of make the whole thing work in a fairly integrated way. One of the key points in both the narrow computer science vision of the stack and in Bratton's conceptualization is this notion of an interface. So that is the method through which the human user, or indeed the various pieces of software with each other, how they engage in a day, on a day-to-day basis. So, for instance, in the case of humans, it used to be that there would be the physical method would be through a keyboard, and now it's through a touch screen. It will eventually, increasingly becoming voice, and then eventually, I would imagine, it might be something like a neural implant. But it's also the patterns of learned and social behavior. What is the appropriate way to interact with Instagram? How does one actually deal with a touch screen? That was quite a big change that Apple brought about in our behavior in the when the iPhone or iOS came out. Now, taking Unreal Engine, which is the software that I've been using, Unity is another one that other people in the art world I think tend to use quite a lot. But taking Unreal Engine as an example, most non-professionals use a visual editor, which is essentially a system of boxes and arrows. And it's what's known as a node-based system, and that's quite familiar for people who have worked with computer graphics. It's used for other applications, but it's also something that one finds in the electronic music world. And using this node-based system, which in Unreal Engine is called Blueprints, one can manipulate and one can populate one's world with 3D objects. One can manipulate them. One can create rules and physics-based rules as to how these objects behave. How do they move through the space? For instance, the gravitational constant could be made 9.8 meters per second, which is what it is in the real world, or it could be made 0 to simulate weightlessness, for instance, or have two suns in the sky to in a sort of science fiction context. So the important thing is this interface, which is called Blueprints, is relatively easy to use. So you have a very fairly low barrier to entry to people wanting to get involved with making worlds or games in Unreal Engine. And I think this is something we see repeatedly in the history of consumer technology, which is that although Blueprints is low barrier to entry, it's actually less powerful than it could be, or less flexible than it could be. So a lot of more experienced developers or programmers drop down into C++. So they sort of ignore this sort of box and arrow metaphor and move down into C++, where they can actually do what they want to do more quickly. And the sort of antecedent for this in consumer technology, for instance, is the early Unix workstations, which were quite esoteric and knowledge based, but one had to master a significant lexicon of commands. But once you did that, then you had something that was very powerful and flexible. Whereas today, your grandmother can use a smartphone, but actually much of the modern technology is a sort of a walled garden. There are specific things that are really easy to do, but it's not necessarily very flexible, nor is it general purpose. And importantly, the platforms that we use are bloated with layers of software to abstract away some of the more difficult, technically more difficult bits. So Apple's OS, whether for the computers or for mobile devices, is basically Unix that has been wrapped in a great deal of user-friendly eye candy. The result of which is that every new update of Apple's OS tends to be a bigger bit of bloat, and that's a trend that we see with Microsoft. You see it with other software platforms. Returning to the game engine as a stack, I see that there's a massively decentered in geographical terms as well as in the terms of the types of agents and the sort of citing of the agents that work with the game engine aspect to contemporary games. So I'm thinking in contrast to arcade games, which are obviously in a physical video game arcade, or indeed the early consoles, which were to a certain extent standalone devices before the networking, the bandwidth was there to play multiplayer games. For instance, in contemporary game engines, there is built-in support for multiple players who may be in completely different parts of the world, while the game itself is sitting somewhere in an Amazon cloud server. So conceptually, the game engine is creating a virtual or immersive world with custom-made physical rules that chews up the time and labor of the people who are playing it, and then feeds that labor back into a internal economy of the game. So there are in-game transactions using currencies that only work within the game, but then those currencies can be exchanged back out into real-world payments. So you have the internal economy that then is externalized into the real world. But all of this really only has tenuous links to any terrestrial geography. So because of the way it's inherently network based. And if you want to view this in sort of a capitalist critique terms, this is the ultimate deterritorial move, where the individual states and individual societies don't matter as much as the overall network, which is much more spread out, which is indeed planetary in some cases. One of the specific areas that I'm interested in is using the game engine to explore and connect some of these spaces. So for instance, the internal world model of the game, which could include trees, clouds, sea, characters, with the architectonic space that the viewer is sitting in, which could be a smart home, for instance, the Internet of Things. There are smart lights, Sonos speakers, Alexa. So connecting those, but also trying to interface into the what I think of as a slightly weird topological structure of data that we both live in, but also are distinctly out of. So, for instance, the planetary network of internet-equipped radiation sensors that a Romanian inventor has made and is selling, and so these sensors send out information on what radiation levels or environmental pollution levels they're recording, and those can be accessed from anywhere. And similarly, the financial markets, which also are an enormous data generating machine, if you want to think about it that way, that operates on a 24-hour cycle and is constantly churning out prices or data about the economy, again, which can be picked up using what's known as an API. So an API basically stands for application programming interface, and those are built-in dictionaries that each software package has that creates protocols for them to talk to each other. So I can access the API for Bloomberg data feeds, for instance, as well as for the radiation sensors, pick up the information from those feeds, and then use them to drive the weather model that is sitting within the video game or the simulation. So, for instance, around the end of March, the VIX, which is a tradable index that measures how volatile, how crazy the stock market is, that VIX index spiked as around 23rd of March when the twin shocks of the plague and collapsing oil prices, when those hit. In response to that VIX spike, which is picked up through the APIs, I can then make the wind speed within the game go up dramatically, causing a tsunami and causing the oceans to sort of drown the island. So basically, the engine is then connected through to the data space, but it's also possible to connect the engine using a different set of APIs to the existing physical architecture that the player is surrounded with, or in an art context, the gallery is surrounded with. So these Philips Hue lights are part of the Internet of Things, and they also contain a interface, an API that allows one to electronically control the color, the intensity, and sequencing of how the lights work. So in a stepping back, what we see here is the internal logics of the game, which are operating within the topology of the data space, are radically affecting our physical environments. And if you sort of extend this out slightly, they can also affect things within our bodies. So an Apple Watch that is at this point just monitoring, but it could theoretically do something different. Or if you have an internet connected pacemaker, and one can easily imagine the sort of dystopian ends that this can be extended through, which are of course the cliches that Westworld and the Matrix explore. I'm also interested in this notion of recursion that I see being built into the Unreal Engine stack. For instance, the user interface of Unreal Engine is implemented in C++, which is the same language and the same libraries that can be used to modify the user interface and to create completely customized environments. Or more generally, the source code of the Unreal Engine itself can be modified by users. And in fact, the company, Epic, encourages people to create customized versions of the software. Now, this isn't on its own an earth-shattering observation, because recursion is something that has a rich history in programming theory as well as the philosophy of mathematics. But from an artistic point of view, it has a mise en abîme sort of quality of ever receding mirrors or of Russian matryoshka doll, in the sense that the inside and the outside borders are very much blurred. And in this work, I've tried to a certain extent explore that through the characters. For instance, there are the flying tuna fish, a translucent blob, kind of a walking around cyborg, and they respond to the drastically changing environmental conditions. For instance, the VIX index that I mentioned above. So, in a sense, they are reflecting the ecosystems that actually surround us, which were collapsing before COVID-19 and will continue to do so once everyone gets back to work. And that sort of reflection between the external world and the internal world of the game is quite interesting to me. So these little bugs here that someone had written in JavaScript, those exist within the web browser, but then they affect things within the game, which I thought was kind of cool. So basically, crossing interfacial worlds between the web technology and the gaming technology. Or for instance, these desktop clocks, which are reminiscent of trading floors or the early Unix desktops. Another blur between the real and the game world is in the architecture of this building. So this is based on Jean Prouvé's Maison Tropicale, which are these flat pack aluminium buildings that he built for the Belgian Congo, and there's quite a lot of interesting story around that, about colonialism and hedge funds that I won't get into now. But in the simulation, I built a copy of the Maison Tropicale for the purposes of the simulation, and then textured the internal walls with patterns that had been with digital patterns with textures that had been posted by two New York-based artists, Eva and Franco Mates, which they had photographed in the Fukushima exclusion zone, and through their studio quite generously made available to artists. So I think you have this in that you have this beautiful thing where the remnants or documentation of a tsunami-related nuclear accident get transmitted as data through the social economy that art has, and then they find their way into a game world that in itself is a simulation of a J.G. Ballard story about the detritus of nuclear weapons testing. If we return for a moment to the open architecture of Unreal Engine, which as I said is epitomized in the modifiable source code, the open access source code, I see, and for me that is showing. I think that shows a marker or perhaps a critique of capitalism. As I think it's being documented elsewhere, the early computer and consumer computer and the web had a very strong open source and liberation ethos, and there was a sense of DIY, garages, indie sort of aesthetic, and that is part of the founding mythology of Silicon Valley. And even if that's not quite true, because as we know, the U.S. government's DARPA program underfunded and gave the motivation for a lot of the developments that ultimately went into consumer technology. So, but leaving that aside, I think there is and was a sort of an aesthetic of plucky individualism that underlay Silicon Valley. Now, Unreal Engine also has a degree of openness as far as the platform goes, but I think the example here is actually, or the idea here is actually quite different. This open architecture is one that is designed to co-opt the users who are creating plug-in modules. So they build either portions of games or specific modules that do particular tasks, such as fog or fire or characters that walk in particular ways, clothing, which are known as skins, that they can then sell on Unreal's or Epic's platform. There's basically a app store style of platform that is used for transactions, and in some cases users may post their work for free in order to bring in future paid commissions, or else to advertise what they can do, hoping to get a job. So essentially, there's this deep marketplace that's been created, and surrounding that, there's an ecosystem of YouTube channels, Discord forums, and there's people on those Discord forums. People are sharing their knowledge and techniques, again for a mix of altruistic and commercial reasons. But I think one of the net results of all of these things is they help hold users within the platforms, within Epic's ecosystem for this game engine, and those users and the work they do, their labor becomes available as a quasi resource to be monitored or monetized by the interest of capital, which is Epic Games, and which incidentally is partially owned by Tencent, a Chinese conglomerate. And that in itself, in the current geopolitical environment, introduces a range of questions that I don't really have the time to explore here. Meanwhile, the way one actually gets a developer license is by signing on to a revenue sharing contract with Epic. And so for what I'm doing, it probably does not matter because I don't think I'll sell this simulation. But it might matter if I were a serious indie game developer with the goal of making money out of the game. And that contract underlies everything that I'm doing and also lets Epic turn the software off, which is that's 2 years of work that would disappear in a flash. So you really have this thing that looks like an open, friendly environment, but actually it is deeply shot through with vectorialist mechanisms, to take Mackenzie Wark's analysis. And if you take that all together, a range of information-centric working practices and modules that are mostly placing power with the platform owner, but however that are also keeping that power in tension with the various content creators, without which the whole ecosystem would fall apart. So in a sense, it's perhaps not so different from the relationships, the power relationships that underpin the art world's gallery, artist, curator, institution network. This then brings me to the actual labor of making a simulation or making a game. In the commercial game space, there are quite large teams that put together games, and it's a little bit like a film. There are people who are working on the narrative plot. There are others that might be making characters in software, but also on green screens, while other people are making customized modules for very specific effects. In this case, I have made most of the simulation myself. However, I've also bought and borrowed in a few 3D models, for instance, the oil platform, or as I said, the bugs on the desktop. And one of the things that comes to mind there, you get this really awkward workflow. So by the time an idea has been translated into a working bit of code, it can be days, and I've often lost the artistic thread or even the idea of why I did this. And this creates a collapse in the intellectual assembly line between the roles that would be separated in a commercial organization, such as what are called creatives and programmers. But it also has some aesthetically interesting aspects. Because I don't really know what I'm doing, there are often accidents. For instance, these tuna fish, which are spinning around maniacally, they basically owe to the fact that I struggled to make the fish fly in any sort of believable way. So far, I've mostly talked about the software and network aspects of the game engine, if you view that as a stack. And to the extent that it has a physical locus, I would place that in the graphical processing unit, what's known as the GPU, which could be on one's own home computer, or it typically may reside in an Amazon cloud server, in an instance of an Amazon cloud server. GPUs date to the 1990s, and they were developed, as the name implies, to do 3D graphics. They execute instructions in parallel, which was quite an exotic concept in the 1990s, but is now is fairly ubiquitous. There is one inside your mobile phone. I'm partially interested in GPUs and parallel processing from the perspective, again, of artistic labor. And what I mean by that is to program a GPU requires a degree of rewiring one's brain. And traditional programming is very much a serial thing. You do one thing, then you do the next one, and then the one after that, and it sort of resembles what I think we perceive as our experience of time. And everything is happening in series. However, when one is working with a GPU, one needs to think in vectors and matrices, and think essentially of the entire viewer's screen as a single mathematical object. And as I said, this involves a certain amount of rewiring, and it means that practices and programs that work on a normal computer have to be significantly re-engineered to work on the GPU, and that ends up being a mechanical as well as a cognitive process. At the level of critique, the GPU is interesting to me because it seems to act as a nexus in what I'd identified earlier as this sort of military, industrial, academic, media complex. For instance, the GPU's ability to process in parallel makes it perfect for machine learning applications, because many programs in AI can be cast into a vector or matrix form. The GPU's architecture also makes it very good for Bitcoin mining and or cryptocurrency mining, because the cryptographic hash problems that must be solved to mine a coin are also very amenable to vector solutions. So you have this genealogy of technology which starts out in the Cold War, in the computing that was developed for the Cold War, for nuclear weapons testing, for instance, the Cray supercomputer, that is now variously used to subvert the state's monopoly on money, incidentally at enormous ecological cost, because of the amount of energy that's needed to mine cryptocurrencies. Or alternatively, it's used to develop surveillance algorithms that at the minimum seem to be racially biased and potentially are leading us into a sort of dystopian cul-de-sac. I think the intimacy that I perceive between the game engines and the GPU and some of these slightly more critical, socially critical concerns are an update of sorts to the ideas that Harun Farokhi was exploring extensively when he was researching the military origins of games and simulations in the Parallel Games 4-part series, for instance. In fact, it feels like everything I'm doing in this project is somehow indebted to Farokhi, in that one is trying to trace how capital, as well as information, pervades, permeates, but most importantly controls how we humans, wetware, how we negotiate this victorialist world.